Okay, so now we are already in our second problem, sample problem number 2. The car below starts from rest and travels along a straight track such that it accelerates 10 meters per second squared for 10 seconds. And then decelerates at 2 meters per second squared. So here we need to talk about accelerate and decelerate. So when we say accelerate, this is positive acceleration. And then decelerate, pasabot ni hinay siya, it means that it is a negative acceleration. So we were asked draw the velocity versus time graph and then the position versus time graph. And determine the time t prime, so as shown in the figure here, this is the t prime, needed to stop the car. Also, how far has the car traveled? Okay, so this is our sample problem number 2. So we were given the acceleration, the first acceleration. Let's say we name that A1, 10 meters per second squared for 10 seconds. And then it decelerates. Our second acceleration is negative 2 meters per second squared. So now we were asked this one, to draw the velocity versus time graph, the position versus time graph, and then to determine t prime, which is the total time or the time needed to stop the car. Also, how far has the car traveled? So we were also asked, how far has the car traveled? How far has the car traveled? Okay, so I'm gonna draw this graph which was just given to us, the acceleration versus time graph. Okay, so on the x-axis there is the time in seconds, and then the y-axis is the acceleration in meters per second squared. So when you're at time t, let's say this is the 10 seconds, the acceleration is 10 meters per second squared. So this is the 10-second time. And then, after 10 seconds, it decelerates into 2 meters per second squared. So, this is the graph, then we have our negative 2 here, acceleration. Until nihunong si car at this point lugar. Let's say we call this time t prime. Okay, so this is the acceleration graph, acceleration versus time graph of the problem. So we have the given, this is the problem. Then we need to find the solution. So first, I would like to suggest to gather the equations needed first before using them. Okay. So naman the acceleration, then pangayon tag velocity and the position, the time, and also this one, the distance. Therefore, we need to get the velocity equation and then the position equations. Okay, so let's start. So for our A1, so this one from 0 seconds to 10 seconds. So when time is great from 0 to 10 seconds, we have an acceleration which is equal to 10 meters per second squared. And then we knew that the acceleration is just equal to the derivative of the velocity with respect to time. So in order to get the velocity equation, we need to integrate this this differential equation. So this becomes derivative of the velocity is equal to a dt. Derivative velocity is equal to the acceleration is equal to 10 dt. Integrate both sides. So integrate this side from the initial velocity, which is 0, to the velocity at 10 seconds. And then we integrate this side from time, since with respect to time ano siya, from time, okay, from 0 to 10 man siya. So from 0, but di lang sa natin buta ang 10, let's just put t here to have our first equation. Okay, so The derivative of the velocity is just the velocity from 0 to v, which is equal to derivative of dt is just t. So we have here 10t, and then plus c. So we know that the integral of this one is a constant, an arbitrary constant, from first time, which is 0 to t. So kung ato ni simplify, we have here v minus 0 is equal to 10. So times t minus 0, which is the lower and the upper limit, plus c, or the constant. So our final equation is 10t plus c. Now we need to know what is this arbitrary constant. So saan man nato siya? So naatay i-assume nga condition. Okay? So ingon this problem, the car starts from rest. It means that the initial velocity at time is equal to 0 is 0 also. So atong time nga 0 seconds, wala pa siya nag-start, wala pa siya nagdagan. So it means the velocity is 0. So substituting these values to this equation, so natay v is equal to 10t plus c. V is equal to 0 is equal to 10 times 0 plus c. Therefore, our constant, arbitrary constant, is 0. So ang ato ang final equation for the velocity 1 is just equal to v equals to 10t. Okay? So manatag naman the acceleration, we have the velocity function with respect to time. Now we need to get the position function. Okay? So we know that the velocity is just equal to the derivative of the position with respect to time. So from this equation, solving this differential equation, we can get a position function. Okay? So we have here ds equals to v dt. And then the velocity is just equal to 10t, so we substitute it here, 10t dt. Okay, so integrating this, so ds, the integral of the derivative of the position from the initial position, so 0 pa to yung initial position, to s, and then from time, so ang time na to is from initial time 0 to, let's just put that t. Okay, para natay function, we get a function. So derivative of s is just s, and then from interval 0 to s equals to 10t. So by power rule, we have this. So the integral ana is 10 na may t, so times 1/2, and then t to the yang power 1 plus 1 plus c. So from 0 to t nga interval. So here we have s minus 0 is equal to 10 times 1/2, that is 5. Then t, yung exponent, 1 plus 1, that is 2 or squared. So 5t squared plus c from 0 to t. So para makuha na to yung ano, okay, let's continue sa. So you have here s is equal to 5t squared minus 0 squared plus c, or just equal to 5t squared plus c. S equal to 5t squared plus c. So unsaan man nato ni pagkuha si constant? So let's assume gyapon, okay? So let's assume that at time is equal to 0, and distance, what po siya na travel, so it means it is 0. So substituting it in this equation, 0 ang s, 0 ang time, then we can solve that the arbitrary constant is just equal to 0. So our atong position function s, ang first position function nato is just equal to 5t squared. From time is equal to 0 to 10 seconds. Okay? So we need this one, the velocity and then the position.